Hey, fourth graders, it's me, Mr. Martins, getting ready to teach you another math lesson. So, boys and girls, this is not just a new math lesson, but today we embark on a journey. We actually are starting a new unit. And as you can tell from the introduction slide here, it's going to be kind of different. It's going to be kind of different. So this unit, Unit 4, is titled Equations and Word Problems. And we're going to get into a lot of algebraic equations and algebraic notation. I know you guys are familiar with that term, but you're going to see it in a new light during this unit, in a new way. And this kind of math is sometimes called abstract math. And the word abstract means that it's kind of different. Um, the word abstract is used in art as well. We have abstract art, and this title is an example of abstract art. So we have art in front of us. Somebody painted it, just like regular art, but you kind of have to look at it a different way to figure out what the artist was trying to paint, trying to say with his or her painting. Um, Abstract art, sometimes you can find images. For example, if you look very carefully, maybe some of you see the image of somebody's face in this abstract art. And so abstract is just another word for complicated or something that you have to look at carefully or with a new set of eyes. And we're going to get into abstract math. In the beginning, I'm going to try and keep things manageable. I'm going to try and explain it in ways that you guys can understand. But at some point, I'm sure it is going to get complicated for some of you, and that's okay. We're going to keep practicing, we're going to keep working at it. And the one thing that we will not do is we will not give up. We never give up. Okay, today's lesson is 4-1. Go ahead and open up your notebook and set it up. We have lesson 4-1 titled Properties and Algebraic Notation. As I'm moving along through this presentation at any time, please make sure to hit that pause button if you need to rewind a little bit so that you are using this video um, your, your best way to encourage your best learning. So that means pausing along the way, rewinding along the way, or when you get to the end, just go back and watch it again. Totally fine. Totally fine. All right, so lesson 4-1, properties and algebraic notation. Our learning targets, and I want you to write these down. I want you to write both of them down. Our learning targets, after you go ahead and hit pause, write them down, and once you're done writing them down, go ahead and unpause it, and we're going to talk about these a little bit. Go ahead and hit pause now if you want. So learning target number 1 is I can solve multi-step math problems using the 4 operations. I can solve multi-step math problems using the 4 operations. And when we say 4 operations, we mean the basic 4. So we have adding, subtracting, multiplying, and dividing. Yep, that's it. The second learning target, I can represent these problems using equations with a letter standing for an unknown quantity. Once again, I can represent these problems using equations with a letter standing for an unknown quantity. What I'd like you to do now is I'd like you to consider how you feel about each of these learning targets. And what I mean by how you feel is where are you right now with them? On our very first day prior to the lesson, what's your comfort level? So on a scale from 1 to 4, 1 representing doesn't sound familiar, even with help, I don't get it. 2 representing sounds familiar, help me a little and I can get it. And then 3 representing I get it, but I could use more practice. And 4 representing ready for a challenge, I can teach others. Go ahead and think about each one of these learning targets and how you feel with them. So let's take a look at these one by one. We have I can solve multi-step word problems using the 4 operations. I'm going to guess that most of you are probably around 3 on this one, maybe 2, maybe 2, maybe even some of you feeling like you're a 4. But I'm going to guess most of you are 3 because we have solved multi-step word problems this year. We've done that. We've solved word problems that have included addition and multiplication, subtraction and multiplication, maybe some division. We've done that. I can statement number 2 says, I can represent these problems using equations with a letter standing for an unknown quantity. I can represent these problems, these multi-step word problems, using equations with a letter standing for an unknown quantity. I'm going to guess that doesn't sound very familiar. I'm going to guess that most of you are probably feeling like you're 1 here. Maybe some of you are going to put you at yourselves at 2, but I'm going to guess most of you are probably a 1 here. Okay, so this is our starting ground. This is our first step. So that's where we are right now, most likely. Let's continue. Today, you will have access to materials if you would like. You don't have to use these materials. There isn't going to be a lesson on how to use them. I simply want to give you a day to investigate on your own before I show you how to use them. And along the way during the lesson, I will give you uh, instruction on where you could be using these materials. So up on the counter, you're going to find some of these yellow hands-on equation boards. They're just laminated paper with scales on them. And these bags that have cubes and pawns in them. And you will only use the red cubes and the blue pawns today. And make sure that whatever you use, you put back appropriately and in the right place. I don't want to lose any supplies. You might notice that you might have a missing pawn. For some reason, 4th graders like to lose those. I'm hoping that you guys are different, but you should have 8 white and 8 blue pawns in the bag. If for some reason you don't have enough, please do not use this as an opportunity to go ask me. I'll be working with students. You might see me working with those students right now. So I want you to handle this independently. If you're short a pawn, it's not a big deal. Let's problem solve. Let's move on. Okay, so those are materials that you can use, but you don't have to. There's no lesson on how to use them. It's just for you to figure that out today. Okay, let's get started. So, quick question. What are some different ways to express the number 4? I want you to go ahead and write down your ideas in your notebook. And if we move on too quickly, remember to hit that pause button and then start it up again when you're ready. Or if maybe you don't have any ideas, you can go ahead and keep going. And then when you do have an idea, hit that pause button and write down some of your ideas. I do want you to engage in all of our different activities. All right, so some different ways to express the number 4. Take a moment to think about that and jot down your ideas. So what I'm going to do is I'm going to break out my scale. I know it doesn't look like your scale, but I couldn't find a good sample of your scale that wasn't a good picture. So I'm just going with this one. So same concept. And I'm going to go ahead and jot down my ideas, or just some of them, for different ways to express the number 4. So here's one example. I can express the number 4 as 2 plus 2. There's one way I can express the number 4. I can also express the number 4. I'm trying to remember how to use my delete all button. Here we go. I can also express the number 4 with, let's see, 5 minus 1. That is also equal to 4. Let's see, maybe this time I can use multiplication. This time I'm going to use multiplication. How about 2 times 2? There's another way to express the number 4. Division. Can division work? Let's give it a try. I'll have to start with a big number that works with 4. 24 divided, not 24 divided by 4. That would be another way to express the number 6. Yeah, you're right. 24 divided by 6 is also a different way to express the number 4. So everything that I'm writing down here, is an example of what we call, let me jump to the next slide. I wish I had 3 hands right now. 3 hands would make this a lot easier for me. Okay, these are all called expressions. Now you might be thinking, well, what is an expression? Well, here is a definition that I'd like you to write down. An expression is like a sentence, but with numbers and math operations. I want you to think of an expression as a number sentence. Okay, if you haven't finished copying this down, go ahead and hit pause so that you can finish before you move on. So remember, an expression is like a number sentence. It has numbers and math operations. So let's go ahead and write some more expressions, and this time we're going to add variables. A variable is a letter, and that letter can represent any value. It's an unknown value, which is why we use a letter, because we don't know what it's worth. Oftentimes, you'll see people use the letter X as the unknown, and that's fine. But what you're going to see me do today is you're going to see me use a variety of letters, because you can actually use any number, or sorry, any letter. And later on in the word problems, those letters are going to represent something. So for example, an expression with a variable might be something like 2 plus m. And in that word problem, maybe the M represents marbles, or I don't know, melon flavored candy. I don't know. Um, and we don't know how many, so we use the letter M. So 2 plus M is an expression. It's a number sentence with terms and operations. 2 is a term, M is a term, and we're adding them. If some of what I'm saying doesn't make sense, don't get stuck on the parts that don't make sense. I want you to fix on the parts that you understand. So focus on the parts that you understand first. So 2 plus m is an example of an expression with a variable. We can also do 4b is an example of an expression with a variable. And you might be wondering, like, what does that mean, 4b? We're supposed to be using operations. We're supposed to be adding, subtracting, multiplying, dividing. What does 4b mean? Well, 4b means 4 b's. So if, for example, b was worth 2, it would be 4 2's. If b was worth 27, it would be 4 27's. Oh, I see what you guys are putting together. It's multiply. Yeah, you're right. So when a number and a letter are together, you're multiplying that letter times that number. So we have 4 b's, or 4 times b. So that's an example of an expression with a variable. Let's delete all that. And how about another one? We have, let's use x this time. X minus 1 is an expression with a variable. We don't know what the x is worth. There's no way as it is for me to figure it out. So I'm just going to call that an expression with a variable. I can't figure out what x is worth here, but there will be times where we can. Okay. And then how about you try one? How about you write an expression with a variable? How about you give it a shot? If you wanted to, you could even go backwards. I forgot to tell you, you could rewind to the beginning and you could try these with your hands-on equation model. See if you can figure that out. Wonderful. Okay, guys, we're going to move on. And I'm just trying to figure out how to use all my gadgets here. All right, so once we understand how to write and recognize an expression with a variable, the next step is that we learn how to simplify expressions with like terms. And notice that I've put quotation marks around simplify and quotation marks around like terms because we have to figure out what that means. Okay, so simplify, I have a slide for. Simplify, write this down, could mean two things. It could mean combine terms that are alike, or it could mean solve, but only if that's even possible, because there are going to be some cases in algebraic equations where it's not possible. We've already seen examples of those, right? Our expressions that we've looked at, we were not able to solve. There wasn't enough information. But sometimes there is enough information for you to solve or simplify. So again, simplify could mean two things. And then like terms, I'll give you some examples of what I mean so that you can understand. So let's say, for example, I have 3a. And so in this case, that means three unknowns. I have three variables. So for those of you who are attempting to use the hands-on materials, you would put a number on the scale because what we have here is three unknowns. So you would put three pawns, three blue pawns, and we don't know what those are worth. And then minus 2a. So does that mean put another two pawns up, or does that mean take away two pawns? And for those of you who said take away two pawns, that is correct. So if I were going to simplify this expression, I would actually say it's 1a. And actually, to be more exact, I would just call it a. Right? There's no reason to put a 1 in front of it when a all by itself means 1a. So 3a minus 2a simplified equals a. And so the 3a and the 2a is what I mean by like terms. We're talking about a's, not different variables. And in this case, whatever a is worth here, it's worth the same here. So if a is a 5 here, it's also a 5 here. And that's why you can combine them. Okay, so maybe that was tricky. Let's take a look at another example. This time I'm going to use x. So we have 2x plus x. Over here I have two x's. And remember, x all by itself means 1x. They're like terms, so I can say that that's the same as 3x. 2x plus 1x equals 3x, or is the same as 3x. So simplifying is just combining those like terms. It's that simple. Let's do another example. This one is a little bit harder, but I want you to try this one on your own. So I have 14 m's plus 3m plus m. Go ahead and take a moment to figure that out on your own. And if you want to, you can do this in chunks. So for example, over here, 3m plus m, remember m all by itself means 1m, is 4m. And then I can chunk that with my 14m to get a total of 18m's. And remember, that's multiplication. 18m's would be m plus m plus m plus n plus m plus m. 18 different times in the shortcut to that repeated addition is multiplication. So 14m plus 3m plus m in simplest form is 18m's. I'm just using simplify to shorten it and make it easier to look at. Okay, good. All right, wonderful. So, new question. We've taken a look at expressions. We've taken a look at expressions with variables. We've talked about simplifying when we have like terms. So the next logical question is, what happens when you add an equal sign? What happens when you add an equal sign? Well, when you add an equal sign, you get an equation. Hey guys, go ahead and jot this down. An equation shows that an expression is equal to something. An equal sign is added to show that expression is equal to something. Think a number sentence with an equal sign. So let's take a look at some examples where we actually solve for the variable. So we're taking a giant step here because we're adding an equal sign, and now I'm teaching you how to solve for the variable. Go ahead and write that title in your notes so you can keep track of what we're doing. So let's say that I tell you that 3a plus 2a, there's that equal sign. Now maybe you were wondering if we were going to put something on the other side. Well, now we are. So on the other side, I'm putting 50. And this is why our background is a balance, because I'm trying to show you that one side is in balance with the other side. So this side right here is equal to 50. And this side right here, obviously, is equal to 50. But we need to figure out what that a represents now. Well, the first thing that I'm going to do is simplify. 3a plus 2a is 5a. And now I'm going to use, if you want to, go ahead and use your pawns. And if you want to hit pause as you set it up, that's fine. So how would you set up 5a? Would you put up a 5 and 1 pawn? No, that would mean 5 plus a. We're talking about 5a, so that's 5 variables. That's right, put up 5 unknowns, 5 pawns. And then on the other side, somehow put up the number 50 using your red cubes. So we have 5 pawns equals 50. And for those of you not using the materials, that's fine too. You're going to use some mental math here. What does each of those pawns have to equal for 5 of them to equal 50? Oh, some of you are thinking about dividing up the value now. Okay, that makes sense. So take your 50 and split it up. Oh, 50 divided by 5. Well, that makes sense too. You guys, yeah, I can read your thoughts. So if we do 50 divided by 5, that means that each one or each a would be equal to 10. Well, would that work? So 3 a's would be 30, and then 2 a's would be 20. Does 30 plus 20 equal 50? Well, yes, it does. So we would check that off, and that one worked out for us. So what I mean by solving for the variable, we weren't trying to get to this answer. That's something that we're used to doing, right? There's an equal sign there, and we're used to putting the answer after the equal sign. But in this case, that 50 was already there. What we didn't know was what the a was worth. And so we had to solve for that variable. We had to figure out what the unknown value was. And in this case, it's 10. Fantastic job. Now, if I'm moving too fast, you make sure to hit that pause button. If I've jumped ahead too quickly, pause and rewind. Totally up to you. You have full control here, guys. Thanks for engaging in the lesson. I really appreciate it. Let's take another example of an equation where we solve for the variable. Oh, wait a second. I tried to skip ahead too quickly. My bad there. So this time we're going to use the letter F, and we're going to add 25 to F. I have no idea what F is worth. At this point, I can't even figure it out until I put an equal sign and a value here. Now I can figure it out. You see, whatever I add, so whatever this number is, whatever F is worth, when I add 25, I get 32. Now, before I continue, I'm not going to simplify here because I don't have like terms. I only have one F, not multiple Fs, so there's nothing to simplify here. I just need to figure out what makes sense. Now, some of you might go ahead and use something like subtraction here, or some of you might use mental math. That's fine too. That's totally fine. It might get a little bit loud in my house, so I might need to pause along the way. Hopefully you guys bear with me here. Okay, so what number makes sense here? Well, some of you might be thinking 5. If I add 5 to 25, I get 30. That's too short. Oh, what if I add 7? All right, I had to pause there for a moment. So hopefully I remember where I left off. My stepsons have some friends over and they were all swimming. I thought I had a moment to finish the video and I ran out of time there. So let's continue. Were we continuing or did I have another example? Actually, I have another example. So let's go back. Let's go back and delete that. Okay, so let's see. Let's try this time. Let's try 8a minus a. As it is, there's no way we could solve that. But when we add an equal sign and make it an equation and put a value on the other side, now we can actually solve for the variable. Now, what you might have noticed is that I have 8 a's on one side minus an a. If you want to set this up with pawns, you can totally do that. So again, you wouldn't be putting up an 8 and then an a because 8 a's means 8 unknowns. And so you would put 8 pawns up and it says that we're minusing an a. So we can simplify that. So 8 a's minus an a equals 7 a's. And on the other side, we have 21. And those two have to equal each other. So what can I do to 7a to make that equal 21? Good. Yeah, absolutely. I can make a worth 3. So if a was worth 3, 7 times 3 is 21, and both of those sides would be the same. Check. Good. So this is all about making our sides have the same value. Hey guys, I have one more prepared for you. And on this one, I want you to hit that pause button and see if you can solve this one on your own. This one is 16y. Oh, that's not even what I wanted to do. I actually wanted to do 16 minus y equals 12. So will I be simplifying on this one? Nope, I only have y's. On one side of my expression, I don't have more than one y. And so I have the number 16, or the value 16, minus y equals 12. And I have to make these two sides equal. So whatever I do here has to equal 12. So what does, you know what, I jumped ahead too fast. I wanted to give you a chance to solve this one on your own. So with that information, if you haven't already, hit pause and figure this one out on your own. Hopefully you hit that pause button, and at this time you've unpaused as we move along. So in order to make that work, y has to equal 4, because if we put 4 instead of y, then 16 minus 4 equals 12, and that checks out. Wonderful. So that's all I mean about solving for the variable. That's all I mean there. Hopefully that makes sense. If it doesn't make sense, remember, after this video, I will be available to answer questions once I have finished up with the group that I have. What we're going to look at now is solving for the unknown. So sometimes the unknown is a letter like M or X or Y. Typically one of those three letters. That's what mathematicians like to use. They like to use the letter M and X and Y and B. I don't know why those specific letters, but they like to use those letters. In math for us, we'll be using a variety of letters, and you'll see that in the next couple of days. But sometimes there is a box, and it's an empty box, and we have to figure out what that empty box is worth. So here's an example of what I mean. I'm going to do 7 times, and remember, we can use a multiplication symbol or we can draw a dot. And my computer's not drawing a dot real well right now, but that's what we'll do. 3 plus 2 equals 7 times, and there's that square. So remember, we're looking at a balance, and whatever is on one side of the balance has to equal the other side of the balance. And right now, instead of tackling the unknown, I'm going to work with what I do know. So on the left side, I have 7 times 3 plus 2, and 3 plus 2 is in parentheses. And what parentheses means here is you have to do that first. So anytime you see parentheses, you always work in the parentheses first. And if there are multiple parentheses, then you work from left to right. So you do whatever is on the left, and then you move on to the right. So what is a 3 plus 2 worth? Yeah, simple, 5. And then what do I do next? Well, I'm going to multiply 7 times whatever I got from adding 3 plus 2. So that's 7 times 5. So the 7 times 5 equals 35. Well, that means this over here has also got to equal 35. Yeah, so a fourth grader might jump ahead too fast, too quickly, and put 35 in that box. Well, 7 times 35 doesn't equal 35. So don't put 35 in that box. The only time you would put 35 in that box if there was a box over here all by itself and no times 7 in front of it. Then you would put the 35. But right now, 35 has to be the value of this entire side. So what's the only number that works in the box? Very good, 5. And you might notice that it's kind of the same equation from the left side. We did 7 times 5 over here equals 7 times 5. Well, that makes sense. It's not always going to look that simple, and sometimes it will. You'll just have to pay attention. Again, if I'm going too fast, hit that pause button, rewind if you have to, use whatever pace you need. Our next example is, oh, gotta hit my pen button, 9 minus 1 inside parentheses times 4 equals our unknown times 4. And I know some of you already see a trick to this one, and that's okay, but I'm going to go the long way about it. So first of all, I have 9 minus 1 times 4 on this side. And I'm going to do what's inside my parentheses first. So 9 minus 1 is 8. And then it says to do whatever answer I get from the parentheses times 4. So 8 times 4, just giving you a moment to think about it. That's right, 32. And so what that means is whatever I do over here has also got to equal 32 because I'm working on a balance or an equation. This side equals 32. Whatever's on the other side has to equal 32. So what's the only number that will work there? Very good. And maybe some of you saw that. Maybe some of you saw, oh, okay, well, 9 minus 1 is 8. So 8 times 4 has got to equal 8 times 4. That would be the shortcut, but some of us aren't ready for that shortcut. Some of us need to see it all the way through, and that's totally fine. Okay, let's jump into another example. And this is our last one, so I'm gonna ask you, once I set it up, I want you to pause it and see if you can figure it out on your own first. So I'll have 3 plus 2, 3 plus 2. This time I'm going to put our unknown on this side, equals 7 times 5. So now our unknown has jumped over to the left side. Is that allowed? Absolutely. What I'm going to do is I'm going to start on the right side because I can figure out what 7 times 5 is. 7 times 5 is 35. So that means everything over here has also got to equal 35. I'm on a balance. There's an equal sign in the middle. One side has got to equal the other side. So if my right side equals 35, my left side has got to equal 35. Well, I have some things to figure out here first. I have some numbers in the parentheses, 3 plus 2, that equals 5. And then 5 times a number has got to equal 35. Well, there's only one number that works there, and that's 7. Now, some of you might have noticed that these are actually different properties that we've learned. Reordering multiplication, reordering is commutative property. In commutative property, when we're working with multiple addition steps or multiplication steps, we can reorder them and it still works out to the same value. Okay, so thanks for hanging in there. We have just one more thing to figure out. We have one more thing to figure out. So this time, let me see if I can get my screen to work. This time, we're going to work with the direction evaluate. And this sometimes is a tricky one for fourth graders, but I know that we can work together to figure it out. So the word evaluate means to see how something works or to see if it works. So anytime I use the word evaluate in this unit, it means to test something, see how it works, see if it works. And let me go ahead and jump into an example of what you would do with this direction. So let's say I gave you the expression 4 times 7 minus c equals, well, right now there's nothing we can do with that, right? Because I'm not going to give you what it equals. But what I am going to tell you is that c equals 5. I'm going to tell you that c equals 5, and now you are going to plug it in to figure out what that expression equals. So it's kind of like what we previously did, except I'm going to tell you what the variable is worth, and then you figure out what the other side equals. Kind of makes sense? Let's give it a try. Well, this is telling me that c already equals 5, so I'm going to cross out the c, and I'm going to substitute it with the 5. And now I can follow my steps. Remember, parentheses first, So 7 minus 5 is 2. And then 4 times that 2 is 8. And that 8 goes there. So when I substitute the C for 5, I get 8. Sometimes math teachers will say plug it in. You're taking the 5 and you're plugging it in. I like to use the word substitute because that's what we're actually doing. You're taking the C and you're substituting it for the 5 that it's worth and then figuring out its value. Okay, so there's one example. Let's try another one. Let's try, oh, I didn't have my pen ready. Let's try P plus 1 inside parentheses divided by 9 minus 4. And right now, there's nothing we can do with that, except for the fact that I'm going to tell you that P equals 19. Okay, well, now what? Now what do we do? Exactly, we substitute. I'm telling you that P equals 19, so instead of the P, we're going to put 19 there. And then 19 plus 1 is 20. And 9 minus 4 is 5. We did our two parentheses first, remember, left to right. And then it says that whatever you get from the first parentheses, go ahead and divide that by whatever you get in the second parentheses. So we have 20 divided by 5, and that equals 4. So we're going to write equals 4. All we did was plug in the 19 instead of P, or substituted. That's right. And then we worked out the equation until we got our final answer, 4. All right, so there's two examples. And this one, after we set it up, I want you to hit that pause button and see if you can figure it out on your own. So this one is 12 plus 3 minus, don't let me trick you here, 5a. And I'm going to tell you that a equals 3. All right, guys, hit that pause button. Yep, hit that pause button. See what you can figure it out on your own. Yeah, even if you just end up staring at this for a little bit, I want you to see if you can manipulate it, figure it out, see what you can do before I lead the way. Okay, hopefully you're coming back from pausing the button because now I'm going to go ahead and start leading the way. So remember, evaluate means to test something out. What are we testing out? Well, we're testing out this expression for when a equals 3. So if a equals 3, we're putting a 3 there, but I don't want to turn that into 53, and it's not 5 plus 3. Remember, 5a meant 5 a's. So we have 5 3's. I'm going to throw that multiplication symbol in there so that I don't accidentally make a mistake, because that's not a 53. 5a means 5 a's. If we substitute a for 3, we have 5 3's, not 53. 5 3's, so that's 5 times 3. All right, so now I'm going to go left to right. 12 plus 3 is 15. 5 times 3 is 15. 15 minus 15 is 0. Did you get that? Is that what you got? I hope that's what you got. If that's not what you got, I'm guessing you made a mistake when you were substituting the a for a 3. And maybe you added it on accident, or maybe you changed it to a 53. Well, now we know. We have to know. 5a means 5 a's. And so when we substitute that a for a 3, that's 5 3's. 5 3's is the same as 5 times 3, or 15. Okay, now before you guys settle up with me and move on to the next thing, I want you to reconsider, whoops, just going to go ahead and delete. I want you to reconsider our learning targets. I want you to think about how you feel now. So as far as that first learning target, that's something that we are going to look at more in the future. That multi-step word problem. Today, we kind of looked at multi-step math problems. What I want you to think about is that second learning target where most of you were a 1 or a 2. What are you now? What are you now? Let me read that to you. It says, I can represent these problems using equations with a letter standing for an unknown quantity. Do you know now what a letter standing for an unknown quantity means? I hope you're more familiar with it. So maybe you've moved from a 1 to a 2. Maybe you've moved from a 1 to a 3. If you've made any progress at all, I'm super proud of that. That's the goal, is to move from one box to the next box, from one number to the next number. And we're just going to keep practicing and practicing and practicing until we get as far close to 4 as we can all get. We may not all get to 4, but my goal is to at least get everyone to a 3. Okay, so that's it for today's lesson. At this time, I want you to go ahead and move on to the homework page. Um, use your notes, use our examples, and if you need to, please refer back to the video while you're working on that page. If you have questions for me, make sure to wait until I'm all done with my small group, and then I will be available to answer your questions, probably shortly after you finish this video. Or who knows, maybe I'm already done and maybe I'm already available to answer questions. If you finish the homework page early, I want you to work on Khan Academy. Nope, don't go on to the next unit. I want you to stay with anything that we've already done. So if there's anything that you need to finish in place value, adding and subtracting, multiplying or dividing, go ahead and finish that up. All right, thanks guys.